Welcome back. Today we're going to be talking about scientific notation and more specifically changing a number from standard form into scientific notation. So the problem with really large numbers like this or really small numbers like this that take up a lot of places with a decimal, oftentimes when they're gigantic numbers, there's not enough space to work with them. And also, when we're trying to make calculations easy, they won't fit in a calculator. I think a calculator generally has about 8 spaces in it, whereas we can see this large number here, 1, 2, 3, 4, 5, 6, 7, 8, 9, 12, has 13 spots. So obviously would not fit in a calculator. And also with these smaller numbers, it's easy to make mistakes, such as putting a decimal in the wrong place or leaving out a 0 in all of these decimal places here. So, to help combat these problems, they came up with scientific notation. So numbers expressed as the product of a factor and some power of 10. So the power of 10 part should look a little familiar since that's what we did with the last couple days. So one thing is the factor must be greater than or equal to 1 and less than 10. So as we see here, this one, 2.45, is in between 1 and 10. So our number there has to be 1 or bigger, or let's put that in a better way here, in between 1 and 9.999. Well, those 9s could go on for forever if they needed to, but it's got to have one whole spot and then the decimal places. So we have some numbers here in standard form and scientific notation, and I just want you to take a look and see if you can think of any patterns that you see here. So hopefully what you notice is that the exponent tells how many places to move the decimal, and it also tells us which direction to move the decimal. And if we notice the ones with a positive exponent here, we took our 3.48, and the 5 tells us we need to move it to the right. 1, 2, 3, 4, 5. We can add these zeros here, and we get this exact same number in standard form. So it's just telling us to move the decimal to the right 5 places. And one with a negative exponent, such as this, tells us we start with our 5.12, and we move our decimal place left 5 places. So 1, 2, 3, 4, 5. Add our zeros in, and we get this exact number here. So all the exponent is telling us to do is what direction and how many places to move our decimal. So pretty easy here to change a number into scientific notation. So here we have our 0.00014. Well, first we've got to change our number to a number with a whole piece and then our decimal spots. So we've got 1.4 here. This 0.00014 was changed to 1.4, and we've got to see how many places would we have to move our decimal to get back to where we started. So 1, 2, 3, and 4, and we would have to move it left to get back there. So our exponent is negative 4. Same thing here, all they did, was put the decimal in between the 3 and the 2 here. And then to get back where we started, we'd have to move our decimal 1, 2, 3, 4, 5, and 6 places, just like the exponent there tells us. So we're going to try a few of these here. So to change this standard number, 23,400, into scientific notation, well, we're just going to get that number in between 1 and 10, which in this case will be 2.34. We're going to be multiplying that by some power of 10, and let's figure out what our exponent needs to be. So to get back to where we started here, we'd have to move our decimal 1, 2, 3, and 4 spots. So our exponent would be 4. Same kind of thing, we're always going to have a number between 1 and 10. So in this case, 1.3 times 10 to some power. Well, put our decimal there, and what direction and how far would we have to move to get to where it started? Well, we're moving to the left 1 spot. So left tells us negative, and 1 spot there, we moved it. So 1.3 times 10 to the negative first power. Continuing along here, we're going to change to our number in between 1 and 10, so 6.55 times, once again, some power of 10, and in this case we've got to move our decimal 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, and 13 places. So we can see if it's a decimal number and we're writing it in scientific notation, our scientific notation number will have a negative exponent for our power of 10. So next up, make our number between 1 and 10, in this case 1.09, times 10 to the, and our decimal would go there, so we need to see how far left we need to move it. So 1, 2, 3, 4, 5, and that would be negative 6, since our number is a decimal number smaller than 1. We would have a negative exponent. And sometimes these are a little bit smaller and easier than we need it to be, so this one here we wouldn't mind working with, but we can still write it out. So we'll get 3.4891 times 10. Well, to get it back to where it started, we would just have to move it twice to the right. And then we can see in these last cases why it might just be easier to write out this, because this will be 5.04 times 10. Well, how far do we need to move our decimal? Well, it's already where it needs to be, so we would move it 0 times. And then for our last example here, we've got we would write out 3.2 times 10, and we would have to move our decimal left, and it looks like left 1, 2, 3, 4 places. So this would be a negative 4 for our exponent. So pretty easy here. You just gotta remember that that number we start with has to be between 1 and 10. Can't be 10 though, it's got to be smaller than 10. So the rest here will be independent practice. So that'll be the bottom section in your assignment on Canvas. So this upper portion of what's labeled as assignment was just the practice problems we did together. So take care of this on a separate sheet of paper, and then go ahead and take your photo and submit it to the Turn-In bin. Thanks, and